Hello, AMC students. I'm just going to do some of these problems on the practice test. So I'm trying to find the cotangent of 5 pi over 4. Cotangent is the reciprocal of tangent, so instead of it being y divided by x, it's x divided by y. If you look at 5 pi over 4 on the unit circle, the x value is negative square root of 2 over 2. And the y value is also negative square root of 2 over 2. That's a big ol' nasty fraction, but it's really one thing divided by itself. So the cotangent of 5 pi over 4 is 1. If I want to do cosecant of 240, cosecant is the reciprocal of sine. Sine is the y value, so cosecant is 1 divided by the y value. So I look at 240 degrees, I see a y value of negative square root of 3 over 2. If you do 1 divided by that, it's 2 over negative square root of 3. Next, finding all the angles that satisfy the equation sine is equal to negative square root of 2 over 2. So there are two locations there. One of those locations is 5 pi over 4, and then the next location is 7 pi over 4. Those are like the 45-degree angles on the bottom of the unit circle. Then, question 3, we want to find the amplitude, frequency, and period. I always start with the midline. Even though that wasn't asked for, the midline really just helps me see what's going on. And I can tell that the midline is at 3, right? Y equals 3. And I can also tell that it goes 3 steps above to 6 and 3 steps below down to 0. So my amplitude is 3. The frequency and the period are related to each other. It looks to me like it does a full rotation right here. From the y-intercept to there is one full rotation. Here's a second full rotation. It does 2 full rotations when it reaches 2 pi, and 2 pi represents a normal circle. So what's my frequency? F is 2. What's my period? Period is pi. It takes the length of pi to complete one cycle, and it does 2 cycles in 2 pi. So there we go with those first couple questions. Next, we have evaluating the following trigonometric expression. Leave your answer in exact form. Tan of 2 pi over 3 means I look at 2 pi over 3 and I do the y divided by the x. So at 2 pi over 3, we have a y value. Oops, I gotta get my pen back out. 2 pi over 3, we have a y value of square root of 3 over 2. That's the y value. The x value is 1/2. And then the sine of 3 pi over 2. 3 pi over 2 is down at the bottom of the unit circle, so the sine is negative 1. If I cancel out the halves and multiply by negative 1, I get negative square root of 3. All right, on the challenge, it's a bit of a pain in the butt, but you can do it. When you look at the left-hand side to equal the right-hand side, all I'm going to do is rewrite everything in terms of sine and cosine. So secant is equal to 1 divided by cosine. So here we have 1 divided by cosine squared times 1 minus cosine squared. If I distribute that, I end up with 1 minus cosine squared of x, all divided by cosine squared of x. And I am trying to make this equal tangent squared. And so in some way, I need to explain how this numerator can become sine, because tangent is sine over cosine. And so how can I make the numerator become sine squared of x? And what I want you to remember is that we have a unit circle. And on the unit circle, you have a point. And the point has an x value of cosine, and it has a y value of sine. But that point is also a right triangle with a radius of 1, hypotenuse of 1. And so I know that this implies that I can do a squared plus b squared equals c squared. In other words, cosine squared plus sine squared equals 1 squared. If you rearrange that, you'll notice that subtracting cosine squared from both sides allows me to make a nice substitution for the numerator there. 1 minus cosine squared is equal to sine. And so with that, I have 1 minus cosine is equal to sine, and sine divided by cosine is equal to tangent. That's not something we covered in detail this year at all. So if you don't feel worried about that one, it's something that just in past years gets touched on, and I just wanted to leave it on the study guide so you can see that on there. Okay, just a little bit more, and then we'll call it good. We're going to graph both cosine and the transformed function on the axes. Cosine has starts with a y-intercept of 1. Cosine of pi over 2, 0. Cosine pi. Cosine of 3 pi over 2. Cosine of 2 pi. Oops, that was a little too high. Should be right down here. Forget about that first point. And you connect your dots, there's your cosine. Now the other one, I have 2 cosine of x minus pi over 6. And so that makes it twice as tall. And that makes it pi over 6 shifted to the right. So I'm going to use a different color. So pi over 6 will be right here. And it's going to be 2 times as tall. Then pi over 6 shifted there. Shifted pi over 6 steps and 2 times as tall. Shifted over. And then there would be another point like right there. Oops. Sorry. Hard to draw on the computer screen. So there's your approximate graph of the cosine value. The domain for g of x, just like every trig function, is negative infinity to infinity, except for tangent, I should say. And the range for g of x is negative 2 to 2. And we put brackets because it touches those values. Okay, and the last one that I'll do for this video, so it doesn't get too long, is to graph this one in terms of cosine. First thing you want to do is always look for the midline. And so I'm drawing a midline there at y equals negative 1. I'm seeing that it goes 3 steps above the midline. Here is 3, or you can see it there. So my amplitude is 3. The period here, I guess I'm just counting by ones, which is a little, let's see, so 1, 2, 3, 4, 5, 6, 7, 8. So it looks like it's going to be a 16, period of 16. So the frequency would be 2 pi over 16. The horizontal shift is 0. Vertical shift is negative 1, because that's the midline. And using that information, I can write y equals 3. Oh, I should mention, I'm sorry. The cosine normally starts at the top, and this one starts at the bottom. So this is either 2 ways of thinking about it. You can think of it as a vertical reflection of cosine, or you can think of it as a shift over by 8. I prefer to think of it as a vertical reflection. So we can go negative 3 cosine 2 pi. Let me move my little screen out of the way. 2 pi over 16 x minus 1. So that's one correct answer. There are all other correct answers as well. And we'll call that good for this video. Please ask for more videos. I'm happy to make them.